Okay, guys. Again, be quiet, because I need to be heard by the video camera, and I can't talk very loud today. So we're going to go through these questions, these multiple choice questions together. And again, on your test, all the multiple choice questions that I'm going to pull from are going to be on Edmodo. I just posted them today, actually. But I'm going to turn them into true-false questions. So let's look at, actually, we're going to look at number 2 first, because this will be a good example of how I'm going to turn it into a true-false question. Electrical resistance is measured in ohms. Alright, so the answer to number 2 is what? E, none of the above. So how could I turn that into a true-false question?
Electrical resistance is measured in volts.
Volts. You'd say false. Or it's measured in ohms, and you'd say?
Why?
What?
You say why and correct it.
What?
Do you have to correct it if it's false?
No. You don't have to correct it if it's false. Okay. So does that make sense how it's gonna, how I'm gonna do the true-false stuff? Okay. Number 1. The current through a 10 ohm resistor, right? The current through a 10 ohm resistor connected to a 120 volt power supply is C, 12 amps. So just V equals IR. Brian?
So are there any problems like number 1 on the test?
So if I was going to turn number 1 into a multiple choice, or to a true-false, I'd say the current through a 10 ohm resistor connected to a 120 volt power supply is 1 amp. True or false?
False.
Does that make sense?
Sí, señor. I guess.
So we would have to choose it.
What?
We would essentially.
Yeah, I mean, you probably did.
That would be.
Yeah. I'm not going to put anything like a true-false question that you need to do 20 steps on or anything like that.
Okay.
Like Kirchhoff's law one or anything like that.
Was going to be the true or false on Friday's quiz or just this first test?
Just the test.
Okay, just this.
Okay. Okay. Number 3. The symbol used to represent resistance in a schematic diagram is D, a zigzag line. Number 4. When resistors are put in parallel with each other, the overall resistance is A, smaller. Remember, when you add more paths, you decrease the total resistance. Number 5. As more lamps are put into a parallel circuit, the overall current in the circuit
Did someone say D? There's no D.
I meant C for decreases.
it is
Oh, okay.
not C, it is A, increases. As you put more things into the circuit in parallel, what happens to the total resistance? It goes down. If the resistance decreases, what happens to the current? Increases. Right, number 6. When one light bulb in a parallel circuit containing several light bulbs burn out, the other light bulbs C burn the same as before. So you can think about that in your house when you turn one light off, since your house is wired in parallel, every other light in your house stays the same. Number 7. In a simple parallel circuit, which of those is true? B is correct. So the current through each branch is always the same. That's not necessarily true. If all the resistors had the same value, then it would be true. B, the voltage across each branch is always the same in parallel. So remember we said that the voltage through each branch is always the same. Value of each resistor is the same, that you can have any value of a resistor. Circuit won't work unless there is a fuse in it. That doesn't even make any sense. And since B is true, it's not none of the above. Okay, number 8. In a simple parallel circuit, which of those is correct?
A. D. It's always D. It's always all the above.
It is D. The voltage across each branch is the same like we saw before. The current through each resistor is inversely proportional to the resistance. So if you have them wired in parallel, the higher the resistance in a branch, the lower the current that's going to be going through it. Does that make sense? Everybody understand that? And current is divided at each branch, so the current, 1 amp goes in, and then if you have 2 branches, 0.75 and 2.5 amps go to each branch. So the current gets divided up when it splits. Number 9. The total resistance of a 9 ohm resistor and a 5 ohm resistor in series is?
Alpha.
A. 14 ohms. Since they're in series, you do what? Add. Okay. Number 10. The total resistance of a 6 ohm resistor and a 12 ohm resistor in parallel is E, 4 ohms. Could any of those other ones be correct?
No.
No. So you don't even have to do any math because it's not 20, it's not 73, it's not 18, it's not 6. Why is it not any of those?
It's always
You don't add them.
It always has to be less than the smallest resistor in parallel. So it has to be less than 6. Okay, the current through two identical bulbs connected in series is 0.5 amps. The total voltage across both bulbs is 140 volts. The resistance of a single bulb is, this one's kind of tricky. If they're identical, how are the voltage drops going to compare across each? Going to be the same. So what's the voltage drop across each bulb? 70.
Wait, that's what
Yes. So you divide 140 by 2 to get the voltage drop across each since they're identical. So you have 70 volts and 0.5 amps. So what is the resistance? 140, so C. Does that make sense, everybody? Okay. 3 resistors with values of 4, 6, and 8 are connected in series. What is their equivalent resistance?
Alpha.
18. Again, could any of the other ones be correct?
No.
No, it has to be greater than the highest individual value for series. So 12 was A. Okay, 13. 3 resistors connected in series carry currents labeled I1, I2, and I3 respectively. Which of the following expresses the total current IT in the system made up of the 3 resistors in series?
Alpha.
A.
Since I'm not responding, it's not
A
A.
and C are the same. Oh, no.
B. Is it Bill?
It's B.
C.
It's definitely
C.
It's D.
It's C because it's
Okay, what's the same in series? Current. So the current through each branch, and if they're just in series, the current through each resistor is the same as the total current in the circuit. Does that make sense, guys?
yeah.
Okay. 14. 3 resistors connected in series have a potential difference across them labeled V1, V2, and V3. Which of the following expresses the potential difference taken over the 3 resistors together? A. In series, the voltage drops all add up to the total voltage in the circuit. Does that make sense to everybody? Remember how if we had 3, voltage drop across this one was 5, 10, 15, and add up to 30. Alright. Number 15. A circuit is composed of resistors wired in series. What is the relationship between the equivalent resistance of the circuit and the individual resistors?
Sorry. B. Wait,
C.
C. Resistance is just the sum of all the individual resistors. Number 16. 3 resistors with the value of R1, R2, and R3 are connected in parallel. Which of the following expresses the total resistance of all 3 resistors? D. So because it's 1 over, you gotta have the negative 1 on the outside of that. 2 resistors having the same resistance value are wired in parallel. How does the equivalent resistance compare to the resistance value of a single resistor? So remember, equivalent resistance is total.
C.
C is correct. When you have 2 identical ones, it's just half the value. So if you do 1 6 plus 1 6, what's that equal? 1/3. You flip that over, you get 3, so it's half. Okay. 2 resistors with values of 6 ohms and 12 ohms are connected in parallel. This combination is connected in series with a 4 ohm resistor. What is the equivalent resistance of this combination?
C.
Sorry, spacing out. Answer is C. Why didn't we need to do any math?
Because
law.
You know it's going to be below 6, and when you add 4 onto it, there's only one that fits.
Yep. So it's not going to be 22 because 6 and 12 are going to be less than 6, like Kyle said. And you add 4 to that, it's got to be greater than 4, so the only answer that can fit is 8. Does that make sense, everybody? Okay, number 19. The current in the circuit increases, decreases, or does it remain the same when you go from the left to the right?
Increases.
Increases. Why does it increase?
Because if you add another path, the resistance decreases, and if the resistance decreases, the current increases.
Exactly right. So we added another path, so that whenever you add another path, the current is always going to increase and the resistance is always going to decrease. And if you look at it from like a kind of a mathematical point of view, what's the equivalent resistance to the 6 and the 5 in parallel now? Is it going to be greater than 6 or less than 6? Less than 6. So we went from having a 6 ohm resistor to having something less than a 6 ohm resistor. Alright, number 20. The total current in the circuit decreases. Why does it decrease?
Because you added a resistor.
We add a resistor in series this time instead of in parallel.
So there's less current.
Increased resistance, so less current. Alright. Anybody have any questions on any of those? Okay, so again, there's a bank of, I think about, I don't know if it's 40 or 60, somewhere around, somewhere between there online. So what I'd like for you guys to do is sometime between now and your tests, look on there. What I'd like you to post questions is on Edmodo, so like there's a post with the link for, or the download for the all the multiple choice questions. If you don't understand one of them, post what you don't know below it, because we're going to spend most of the class time from here on out doing practice problems like Kirchhoff's law and the resistance things. Does that make sense?
Yeah,
Anybody have any questions? Alright, we are done.